AWS EMR Service hands-on demo. In this section, let's get our hands dirty and look at the AWS EMR Service in a little bit more detail through the AWS Admin Console so that we can learn to create and launch a cluster. What are the objectives of this section? Familiarize ourselves with the AWS EMR console, create a transient cluster with a single step, and then create a long-running cluster, and then interact with the cluster because it's going to be a long-running cluster by executing a step. We can configure a step and execute the step. So these are the four things we're going to do. Right? Let's do the live demo. Here I am logged into my AWS Management Console. I am in the Oregon region. If you recall, EMR, which is the Elastic MapReduce, is actually a regional service. If you want to get into the Elastic MapReduce service, you can go to the Analytics section, and here we have EMR, which is the Managed Hadoop Framework. Click on that. That puts us in the EMR service. You will notice that I have several clusters that I had already created. All these clusters were created and they have been terminated because you can see that their status is terminated. If you want, you can only see active clusters. If I click on active clusters as the filter, I will not see any of the clusters that I had already created and terminated. Let's go ahead and create a cluster. Create cluster. When you create a cluster, you get to the screen that allows you to create the cluster using quick options. There are a couple of modes to create a cluster. We talked about two different modes. One is the quick options and the other one is the advanced options. Here's the advanced options, here's the quick options. It's called quick options because all it takes is a few fields to be filled and then you can create a cluster. There's not too much configuration that goes on here. Whereas when you go to the advanced options, there's a lot of configuration that you can do. It's much more detailed. We'll look at the advanced configuration in the advanced section, but I just wanted to tell you that you have more control in the advanced configuration. Let's go back to the quick options. Here we are back in the quick options. So I would like to create a cluster. I'm going to give it a name called Simple Cluster. I want logging to be turned on. It's by default on. If I click on logging, I'm disabling it. When I click on it, it tells you where the log files are going to be stored. It'll be stored in S3. Okay, let the logging be on. And then it says launch mode. Launch mode is cluster or step execution. If you say cluster, that means this cluster will be created in the long running mode. In other words, it's not going to be a transient cluster. It's going to be a long running cluster with which you can interact. Let's change it to step execution, which is going to be a transient cluster. So the idea here is that we'll launch the cluster. We will configure the cluster, which is step. Once the step is executed, the cluster will shut down. So if the cluster comes up, the step is executed, and then the cluster shuts down. If you notice, when I clicked on step execution, there's something called add steps that came about. Let me show you that. If I go back to cluster, add steps went. It's not there anymore. Now add steps is here, is available. So I can add my steps, right? No add steps, add steps. And now I'm going to add a step for my cluster. Okay, there are different options of steps that we can add. If you notice, I said you can have a Hive program, Pig program, Spark program, or even a custom jar program. I'm going to pick up the custom jar program because I wrote a MapReduce program that allows me to do word count. Remember the word count program that we talked about? I've already written that program. So that's the custom jar. Configure. Now I'm going to actually configure the step. The name is going to be word count. So I'm going to call it the word count step. Then it says, okay, where is your MapReduce program? Where is your custom jar file? Well, the custom jar file should be located in S3. You're expected to put the program in S3. Now let's go back to my S3 management console. Here I'm in my S3 management console. And you'll notice that I have already created a bucket called EMR demo bucket. We click on that. Underneath it, I have a folder called job. That's where I have created my program, wordcount.jar. That's my application program, which is what I'm going to be referring to as part of my configuration. And then there's also a folder called data in. That's where I've placed the data files. I have 3 books, Adventures of Huckleberry Finn, Alice in Wonderland, and Pride and Prejudice. So these are the 3 files for whom the word count is going to be calculated. Right, so that's the bucket. Let's go back to Elastic MapReduce. So the name of the jar location, that should be the S3 bucket. And the cool thing is when you click here on the folder, it's the S3 browser. It says which one of these buckets is yours. Well, EMR demo bucket is mine. In fact, all these buckets are my buckets. But this is the bucket that I'm interested in. Inside it, there's a folder called job. Inside it, there's a file called wordcount.jar. That's the fully qualified S3 bucket name for that file. Select it. Okay. Now it's asking me, are there any arguments to this MapReduce program? Yeah, there are arguments to this MapReduce program. So let's go ahead and pass those arguments. The arguments are word count, because that's the name of the class that contains the main method, followed by minus capital D, map reduce dot job dot reduces equals 1. So that's a property that I'm passing to my word count program, which basically says that the number of reducers that I should have is only 1. I only want 1 reducer. And then I need to pass to it the name of the folder where the input file is located. That should also be in S3. Let's go back to my S3 browser. You'll notice that under my EMR demo bucket, there is data in folder. That's the data in folder. That's the folder that I'm going to be passing as an argument. So what I'm going to do is cut and paste this URL, and then it's data in. That is going to be the folder where the input data is, and then I'm going to say it's data out. That's the output folder. That's where the results are going to be placed. Okay, so let me make this a little bit bigger. What I'm saying here is that I would like to run this jar program as a step. This is the name of the class that contains the main method. The number of reducers should be set to 1. That's a property that's being passed into my Hadoop program. And then the first argument is the name of the directory, which is EMR demo bucket / data in. That's the folder where the input files are located. There are 3 files in that folder. And then the results, when the MapReduce processing is done, the results should be placed in the data output folder. Now it's important to realize that the data out folder should not exist when you're running your MapReduce program. If it does, it'll give you an error. So everything is good. And then it says action on failure. It says, well, if this step fails, then what do you want me to do? Do you want me to continue to the next step? Do you want me to cancel and wait? Or do you want me to terminate the cluster? So these are options that you can choose. I'm going to say continue. Of course, there's nothing else left, in which case the cluster will terminate after this. So that's good enough for me. Add. So we have configured a step. Now we have the option to choose the software. We can choose between the Amazon vendor or the MapR vendor. If we choose the Amazon vendor, we have EMR 410 and 400 as the options. We want to choose the latest one. If we choose MapR, we have choices of M3, M5, and M7. Let me go ahead and choose EMR 410. Then we get into the hardware configuration section. What type of machine do we want? It's M3 XChar extra, it's M3 extra large. Let's take that. The number of instances, it says 3 instances, which makes it as 1 master instance and 2 core slave instances. That's what we have. If you want, I can change it to 4. If I change it to 4 nodes, notice it says 1 master and 3 core nodes. If I change it to 10, it'll be 1 master and 9 core nodes. Let's keep it at 3 right now. And then we have the security policies. We'll let it go for the time being. And then I'm going to create a cluster. Hit the create button. Now before I hit the create button, let me just kind of review what we did. We said the name of the cluster is simple cluster. We want logging turned on. The logs will be placed in the S3. I can actually choose where the log should go to. And click here and select the logs folder where the log should go. We said we want the step execution. In other words, the cluster will come up, execute the steps, and will shut down. When we did that, we had add steps as options that came about. We added a step. We can add more steps if we want, but 1 step is good enough for the time being. We chose Amazon EMR 410, and then in terms of hardware, M3 extra large. The number of instances is 3, 1 for the master and 2 core nodes. Let's go ahead and create the cluster. Now this creation is going to take a few minutes, close to 5 or 6 minutes. So at this point, the EC2 instances are being launched, and then the Hadoop software being installed on top of them. And then once everything is done, it is going to run the step that we asked it to run. Okay, so if you look at this, we have monitoring, we have hardware, steps. Let's click on steps. We have configured 1 step, but the interesting thing is it has 2 steps. There is 1 step called setup Hadoop debugging. The other step is called the word count step. Now the word count step is the step that we configured into the cluster. But then there is already a default setup Hadoop debugging step that's already there. Even the setup of Hadoop is considered to be step within the Hadoop EMR or within the AWS EMR service. Okay, at this point, the cluster is coming up. I can even go back to my cluster list. Notice the cluster is starting. Go back to active clusters. It's been a minute. It's going to be a while before the cluster comes up. It takes about 4 to 5 minutes at least for the cluster to come up. Don't forget, it has to launch the VMs, install the software, get everything configured, and then execute the program also towards the end, which is 1 step for us. So let's wait. At this point, I'm going to pause and then come back in a few minutes once the cluster is ready. It's been 4 minutes. It's still saying that the cluster is starting. I can click on the details of the cluster. Notice it says that the 2 steps are pending. Well, 1 step is the setup Hadoop debugging, where they are actually setting up some things within the machines for debugging purposes. And then the 2nd step is the word count step. They both are pending at this point. They've not been executed yet. Go back to cluster list. And let's see what's happening. It's been 5 minutes. Still starting. It's been 6 minutes. Now it says it's running. Okay, great. The cluster is running at this point. Click on cluster, steps. Setup Hadoop is done. The word count step is running at this point. So what it's really doing is running the word count program. There are 3 input files in the input folder. It's going to be going through them line by line. The word count program will be executed, and then it will generate 1 big file in the output directory that contains words, which are unique words, and the number of times those words appeared across the 3 different books. So if everything goes well, we should be able to see in the S3 folder the output of the program. Go back to the cluster list. Terminating. All steps are completed. So at this point, the cluster is shutting down. As you can see, we talked about the different states of the cluster. You saw some of the states right now as part of this simple cluster. It was starting, and then it was running, and then it's terminating, and it'll be eventually terminated. I'm going to wait for the cluster to terminate completely. I'm going to pause until then. Finally, the cluster is terminated. If I click on all clusters, here's the simple cluster. Notice it's terminated. So the job is done. Now let's go back to my S3 management console. There it is. Notice there's the data out folder. If you click on data out, there's the output of my MapReduce program. Underscore success is a marker file. It's a 0-byte file that indicates that the job was successful. Part R is the reducer number 1. There was only one reducer that we set up. And the entire file is part-r-00000. That's how Hadoop MapReduce names its MapReduce output file. To be precise, the reducer output file. If there are 3 reducers, there will be 3 output files in the name of part R00000, part R00001, part R00002. Okay, so if I click on this file and say open, the file will be opened. It actually got downloaded. If I open the file up, you will notice that the file contains a list of every word that's in those 3 books and the count of how many times it appeared. For example, the word then appeared 103 times. The word that appeared 35 times. The word sometimes appeared 8 times. And notice the output is actually sorted. Right? So that's the word count program. So in this demo, we created a simple cluster. We configured it with a simple step. So when the cluster came up, it executed that simple step, and then the cluster terminated. At this point, I would like to create a cluster, which is a long-running cluster. Let's say create cluster. I'm going to say long-running cluster. Enable logging, that's fine. In this case, it's not step execution, it's just cluster. Amazon, EMR. And by the way, these are the default applications. You can say what applications you want. These are all packaged, pre-packaged. So it says that you'll get Hadoop, Hive, Hue, Mahout, Pig, and Spark. If you choose this, all you'll get is Hadoop, Hive, Pig. If you choose this, you'll also get the HDFS and Hive Metastore. So these are all different bundle packages. You'll see in the advanced sections you have more control. But anyway, let's take the default applications, which means it's going to give you Hadoop plus Hive plus Hue plus Mahout plus Pig plus Spark as part of your package, software package. We want 3 instances. Then we'll go ahead and create the cluster. So in this case, notice I don't have any steps. Go ahead and create the cluster. Oh, it says that if you're going to be doing a long-running cluster, you need to provide an EC2 key pair, because you can potentially log into the cluster to interactively work with the cluster. So let me go ahead and select a key pair. Mr. Velu is the key pair that I'm going to select. And then I'm going to say create cluster. All right, so the cluster is being created. There are no steps. Cluster, it's a long-running cluster. It's going to come up. It's starting. Now when it's a long-running cluster, it's going to come up, and then it's going to just wait for me to interact with it. I'm going to pause the video now until the cluster gets into a state where I can interact with it. Well, before I do that, I'm going to change the filter to active clusters. All right, so it's starting up right now. Let's wait. It's been 4 minutes. If you notice, there's really no steps in this cluster. Let's go ahead and click on long running cluster. Let's look at the steps. We did not really configure any steps, but you'll notice that the EMR guys themselves have configured a setup Hadoop debugging, which is really a step that they have introduced, which allows to set up the machine for debugging purposes. That's the only step that's there, and that's pending right now. Let's go back to our cluster list. Once everything is started, it is going to execute that one step, which is to initialize the debugging. And then after that, the cluster should not shut down. It should wait for me so that I can interact with the cluster. It's one of those long-running clusters that will be terminated only when you want to terminate it. It's been 5 minutes. I'm going to be pausing the video and waiting for the cluster state to change. After 7 minutes, the cluster got into a state called waiting, which means it's waiting for the user to interact with the cluster. Right, so how can we interact with the cluster? I can click on long running cluster. I can add a step. I'm going to say add a step. I'm going to add the same step again that I did before. It's going to be a custom jar, my word count program. And then it says, what is the location of the jar file? I'm going to say it's EMR demo bucket, job, word count jar. I'm just running the same program. Just wanted to show you how I'm running it differently. This time I'm running it as an interactive cluster. So it'll be word count. And then dash D map reduce dot job dot reduces equals 2. This time I want to have 2 reducers. We have 3 input files, which means there'll be 3 mappers, but in terms of reducers, by default there is only 1 reducer, but now I'm going to set the reducer to 2. Then I need to give the input file location that we know is slash data in, and then the output is going to be slash data out. Now I'm going to go ahead and run this. This is going to fail, and the reason it's going to fail is because the output folder already exists. The output folder cannot exist when you are running a MapReduce program. We know that the output folder exists because the data out folder is already there. Let's go ahead and run the program interactively. But by the way, before I do that, it says continue. It says if the program step stops, if it fails, what do you want me to do? Cancel and wait, or terminate the cluster, or continue? I'm going to say cancel the job and wait. Alright, so click on add. So we just submitted a job. I'm interacting with the cluster right now. Let's see what happens. The job is pending. Soon it will run. And I'm hoping for it to fail because I know that the output folder exists. It's still pending. Finally the job failed. Actually, to be precise, the step failed. Okay, so the step failed. Reload this. I can click on standard error, and it says the output directory already exists. That's the problem. All right, let's fix it up and run it again. So close that file. Let's go to our S3 console, delete the output folder, and let's go ahead and try to run the job. Right, this time I'm going to add a step again. Again, I'm working interactively. It's a custom jar file. It's going to be called my new word count, and then the location is going to be EMR bucket job word count.jar. Argument is going to be word count, that's the name of the class that contains the main method, followed by -d MapReduce dot job dot reduces equals 2. We want 2 reducers to run, and I'm going to cut and paste this prefix followed by slash data in, that's where the input folder is going to be, slash data out, that's where the output folder is going to be. If it fails, cancel and wait. Otherwise, wait anyway. It's going to wait anyway. So let's go ahead and add. Okay. Let's see how it goes. This time I'm hoping that the program will run. It's pending. I'm going to pause the video. I'm going to come back once the job is done. There it is. The job is completed. Which means if I go back and look at the output folder, reload the S3 bucket, there's the data out folder. Look at that. I have several reducers now at this point. 1, 2, 3, 4, 5, 6, 7 reducers will run. If I click on the one of the files, there's all the different words and the number of times it appears. Now the way the MapReduce works is that no two file will have the same word, because the reducer is partitioning based upon the keyword, and every keyword will go to one reducer. Well, I know that this class is not on big data processing using Hadoop, but I just wanted to kind of point out to you how the reducers work. One thing that does bother me is that I had set the number of reducers to be 2, and so I expected 2 output files, but I see 6 or 7 output files. Well, why is that the case? Why is it that the EMR is not honoring my number of reducers that I wanted? Well, let's check it out. Maybe I made a mistake. Let's go back to our steps. This is the completed steps that we ran. Click on the step. These are the arguments that we passed. And I say word count is the name of the program. I say -d MapReduce.job.reducers equals 2. I set the reducers to be 2. Oh, wait a minute. The word MapReduce is misspelled, which is the property name that's misspelled. And that's the reason why I ended up getting so many files, because there were many reducers that were run. And for every reducer, there's an output file that gets generated. In this case, because my property name was incorrect, it basically set the number of reducers to be the default, which is really the total number of reducers allowed in the system. So it ended up bringing a lot more reducers, which is fine, but it was kind of bothering me that I didn't have 2 output files, which is what I expected. All right, that explains the mystery. Okay, so that shows you how you can launch a long-running cluster and interact with it. Okay, so we're back into our cluster view. I'm going to show only active clusters. Now I want to terminate the cluster. I click on it and I say terminate. That should terminate the cluster. And that's how you terminate a long-running cluster. Let's wait for the termination to take place. Finally, the cluster is terminated. If I look at all clusters, you'll notice that the long-running cluster has been terminated. Okay, so as part of this section, we familiarized ourselves with the AWS EMR console. We created a transient cluster with a single step. The cluster came up, did its work, and then the cluster shut down. And then we also created a long-running cluster where we were able to interact with the cluster. We were able to create a job, and that job failed, and then we created the job again with the appropriate parameters, and then the job worked. You can keep working with the cluster like that, and then once you're done, you can terminate the cluster.